Very good morning to everybody. Myself Arun Ranjan Naik, HOD Electrical Engineering, Nilachal Polytechnic Electrical Branch. Today I am going to explain regarding Chapter 8 of GTD subject, Economic Aspect. First, base load. On varying the load which occurs almost the whole day on the section is called as base load. Peak load. The various peak demands of load over and above the base load of the station is known as peak load. It is also known as peak demand. Connected load. The sum of the continuous rating of all the equipments connected to the power system is called connected load. Maximum load. Maximum load is the greatest demand on the given period during a given period. It is also known as maximum demand. Average load. Average of all the loads occurring at the various instants on the generating station is called average load, or the total electrical energy delivered in a given period divided by the time period is called as average load. First one is average load. Average load is equal to kilowatt hour energy supplied in a period divided by time period. Daily average load, that is kilowatt hour energy supplied in a day by 24. Monthly average load, kilowatt hour energy supplied in a day by 24 into 30. Variable load, the load on the power plant varies from time to time during uncertain demands of the consumers, is called as variable load. Effect of variable load. Need of an additional equipments, increase in production cost. Interconnected load. The connection of two or more loads in parallel condition is known as an interconnected load. Advantages. Exchange of peak loads, use of older plants, ensure on economic operations, increases diversity factor, reduces plant reserve capacity, increases reliability of supply. Next come to the base load plant. The base load plant is a type of plant which supplies to a constant load demand in a more efficient manner. Such plants run 100% of the time. For example, nuclear or coal-fired plants. Peak load plant. The peak load plant is a type of plant which supplies to both constant load demand as well as maximum demand. These plants helps over short-term 15% demand peak. Gas turbine hydro plant can be used. Interconnected grid systems. The connection of several generating stations are connected in parallel is known as an interconnected grid system. Next factor is load factor. The load factor is defined as the ratio of an average load to the maximum load. Mathematically it is written as load factor is equal to average load by maximum load. Next, diversity factor. The diversity factor is defined as the ratio of sum of individual maximum demand on the power plant. Diversity factor is equal to sum of individual maximum demand to the maximum demand of the power plant. Next, utilization factor. Utilization factor is defined as the ratio of maximum load to the rated capacity of the plant. Utilization factor is equal to maximum load by rated capacity of the plant. Capacity factor. Capacity factor is defined as the ratio of average load to the rated capacity of the plant. It is also called as plant capacity factor. Capacity factor is equal to average load by rated capacity of the plant. That is equal to total energy output in a period divided by rated capacity of the plant. The demand factor. Demand factor is defined as the ratio of maximum demand on the station to the total load connected to the plant. Demand factor is equal to maximum demand by total connected load. Reserve factors. Reserve factor depend as ratio of load factor to the capacity factor. Reserve factor is equal to load factor divided by capacity factor. Plant reserve capacity. The plant reserve capacity depend as the difference between rated capacity of the plant and the maximum demand on the plant. Reserve capacity is equal to rated capacity of the plant minus maximum demand on the plant. This coincident factor. Coincident factor depend as the ratio of capacity factor to the load factor. So coincident factor is equal to 1 by reserve factor, that is equal to capacity factor by load factor. Load curve. The curve showing the variation of load on the power station with respect to time is known as load curve. The load on the power station is never constant because it varies time to time. Types of load curves. The load variations during the whole day is plotted against the time is called daily load curve. The load variation during the whole month is plotted against the time is called monthly load curve. This can be obtained from the daily load curve of that month. The load variations during the whole year is plotted against the time is called yearly load curve. This can be obtained from the monthly load curve of the particular year. This is the graphical representation of the load or load curve. This is the curve drawn between the time in hour to the power demand in kilowatt. So this one is the nature of the power curve. This one is the base load. From this point to this point, there is average load. From this point to this point, nothing but the peak load. Significance of load curve. The area under the load curve represents the energy generated in the period considered. The area under the curve divided by the total number of hours gives the average load on the power station. The peak load indicated by the load curve is the graph represents the maximum demand of the power stations. The load curve helps in selecting the size and number of generating units of power stations. The load curves gives full information about the incoming load. The load curve helps in deciding the operation schedule of the station. The load curve also helps to estimate the generating cost. Load duration curve. When the load elements of the load curve are arranged in order to of descending magnitude, the curve thus obtained is called a load duration curve. This is the time versus load curve. This is at 6 p.m. between the 8 a.m. 6 a.m. to 8 a.m. the power consumption is 10 kilowatt. With 6 p.m. to 2 p.m. the power consumption is 35 kilowatt. From 2 p.m. to 3 p.m. the power consumption is 24 kilowatt. From 3 p.m. to 6 p.m. the power consumption is 30 kilowatt. 6 p.m. to 6 a.m. the power consumption is 3 kilowatt. This is the load duration curve. This is the time versus load. This is 35 kilowatt. This one is 30 kilowatt. This one is 24 kilowatt. So at 0 time, 0 to 6, the power consumption is 35 kilowatt. At 6 to 9, the power consumption is 30 kilowatt. From 9 to 10, the power consumption is 24 kilowatt. From 10 to 12, the power consumption is 18 kilowatt. From 12 to 24, the power consumption is 3 kilowatt. Significance of load duration curve. The area under the load curve and the corresponding chronological load curve is equal. The load duration curve represents total energy delivered by the generating station with optimized operating units. Load duration curve gives a clear analysis of generating power economically. Proper selection of base load power plants and peak load power plants becomes easier. Important definitions of the load curve. First one is base load. Unvarying load which occurs almost the whole day on the station is called as base load. The peak load, the various peak demands of the load curve and above the base load of the station is known as peak load. It is also known as peak demand. Connected load. The sum of the continuous ratings of all the equipments connected to the power station is called connected load. Maximum demand. The maximum load is the greatest demand on the given period. During a given period, it is known as maximum demand. Average load. The load total energy divided in a given period divided by the time period is called average load. So average load is equal to kilowatt hour energy supplied in a period divided by time period. Similarly, load factor. Load factor is defined as the ratio of average load to the maximum load. The load factor is equal to average load by maximum load. Diversity factor is defined as the ratio of sum of individual maximum demand to the maximum demand of the power plant. So diversity factor is equal to sum of individual maximum demand to the maximum demand on the power plant. Capacity factor. The total energy output in a period related to the rated capacity of the plant. Demand factor. Demand factor is the demand on the ratio of maximum demand on the station to the total connected load in the power plant. So demand factor is equal to maximum demand all divided by total connected load. The reserve factor. The reserve factor is defined as the ratio of load factor to the capacity factor. The reserve factor is equal to load factor divided by capacity factor. Next one is plant reserve capacity. The plant reserve capacity is defined as the difference between rated capacity of the plant and the maximum demand of the plant. Reserve capacity is equal to rated capacity of the plant minus maximum demand on the plant. Next, cold reserve. Cold reserves is that reserve generating capacity which is not in operation but can be made available for service. Hot service reserve. Hot reserve is that reserve of generating capacity which is in operation but not in service. Spinning reserve. Spinning reserves is that reserve generating capacity of this capacity which is connected to bus and is ready to take the load. Types of loads. First one is residential load. This type of load includes domestic lights, power needed for domestic appliances such as radios, television, water heater, refrigerator, electric cooker and small motors for pumping water. Commercial load. It includes lighting of shops, advertisements and electrical appliances used in shop and restaurants, etc. This load occurs for some hours during the daytime. Industrial load. It consists of load demand of the various industries. The magnitude of this type of load depends on the type of industries. Municipal load. It consists of street lighting, power required for supply, water supply and drainage purposes. This pumping purposes occurs at the night time only. So municipal load occurs only during night time, but industrial loads